Dear students, good evening. Uh, in the last class, we discussed about chromatography, right? So, in this chromatography, we have two categories: liquid chromatography and gas chromatography, right? So, these are covered. And apart from these two, we also covered mass spectrophotometer, mass spectrometer, right? So mass spectrometer, the basic principle, mass mass of the molecule in a sample that is measured. And today we see one more new concept, nothing but NMR. So what is NMR? NMR nothing but nuclear magnetic resonance. So it is a it's a powerful technique for analyzing molecular structures. Molecular structures. So different molecules having different structures. You recall once again your chemistry, chemical in the intermediate or in the BTech first year. You recall once again the engineering chemistry, right? So the different molecules having different structures. For example, take a neutron or hydrogen, and uh, maybe some other chemical chemicals that they have some its own structures, its own structures. Suppose if you take any sample, for example, sample nothing but mixing of all these molecules, right? Separate molecules. So in that mixture, we want to analyze this, how the structure of a molecule is present and how this structure will relate to other molecule structures. How it depends, how it is related. That we want to analyze it. It is special powerful technique but nuclear magnetic resonance. So under this principle, we have a instrument nothing but NMR spectrometer. NMR spectrometer. So generally, uh, this NMR spectrometer basically useful for uh, identification of the molecule structures, and this application mm, this application will be extended from smaller um, smaller sample sizes, smaller and smaller sample sizes. See, we come across with the other techniques so far what we discussed. They have some limitations, but come to the case of NMR, it is a powerful technique as we know that because it accepts a smaller and smaller samples for analyzing molecular structures. And with this NMR, we are knowing that how these molecules function and relate to each other, relate to other molecules structure, how they are related to from one molecule to other molecule, how they are related. The relation between the two molecules can be also be analyzed. Okay, and generally, yeah, see this NMR spectroscopy technique, which is based on absorption of electromagnetic radiation in the radio frequency region of 4 to 900 megahertz by nuclei of the atom. So this NMR will work on the frequency range of 4 to 900 megahertz. What is that 4 to 900 megahertz? It is a radio frequency in the electromagnetic spectrum. Electromagnetic spectrum. So in the complete electromagnetic radiation, we have taken radio frequency of some range. That frequency is useful for study of molecular structures, molecular structure in the sample. So for this, so we need some sources, nothing but the sources of energy in NMR is radio waves. So basically, the source required is radio waves, radio frequency signal. otherwise RF radiation, radio frequency radiations, which have long wavelengths, have more than 10 power 7 nanometers, and thus very low energy and frequency. So 10 power 7 being nanometers, imagine the wave, right? So these radio frequency wavelengths are very much important for analysis of these samples. Right. When low energy radio waves interact with molecules, that's what happening. They can change the nuclear spins of some elements. So because if you take a nucleus having some neutrons and protons. Outside the nucleus, electrons. Exactly. So electrons are they are spinning and the protons are spinning into their own axis. Right? That's called spinning, rotating or moving its own axis. Its own axis. That's called spin. So when low energy of radio waves are interact, what happens? With the molecules, if any external radiations are interact with the molecules, what happens? The molecules will absorb the radiations. Will absorb the radiation. And the atoms in the molecules, the atoms when the atoms may acquire some energy with some radio radiation, radio frequency radiation. They may move from low energy states to high energy states. That's what the meaning of this. So the meaning of this is they can change the nuclear spins of some elements. So when the molecules acquire some extra energy through its radio waves, so the atoms may excite from low energy states to high energy states. That's what happening, changing the state. Changing the state. That's also called here in our language spin. It's called spin. So this totally spin depends upon um, the number, that is quantum number. That is it depends upon the quantum number. Yeah, you see that principle. You see that how the spin depends upon the quantum number. You see. So principle of NMR. See, it is the molecules. These are the molecules. These are molecules we are observing with no external magnetic field. No external magnetic field is applied. So they are irregularly in position. The molecules are irregular in position. So the theory behind NMR comes from the spin of the nucleus and spin of the nucleus without an external applied magnetic field. The nuclear spins are random in direction. Random in direction. Suppose for the same, if you apply if you apply with external magnetic field, what happens? See the molecules directions. They have its own spin, same directions, same spin, orientation, same orientation. So, but when an external magnetic field E not represented, E is applied, what happens? The nuclei align themselves either with or against the field of the external magnet. See that diagram? So they have some same orientations with directions. But in the previous diagram, no external magnetic field, so they are random in nature. But with this applied external magnetic field, there is there is right directions and orientation. That means its own spin. Own spin. Fine. So and the theory behind this is why we need to study this NMR means the NMR provides, listen carefully, the NMR provides an accurate and non-destructive method of determining structures in liquids and soluble chemical compounds. You take any liquids, for example, sample is liquid, you can analyze very accurately with this NMR spectroscopy. Suppose the sample is soluble soluble chemical compounds. For that also you can analyze very accurately, right? And one more advantage this is, and what is the basic principle behind this? What is the basic principle about this NMR spectroscopy? The basic principle is the study of absorption of radio frequency radiation, the study of absorption of radio frequency radiation by nuclei in a magnetic field, by a nucleus in a magnetic field. Suppose to take any sample, sample having some molecules, atoms, right? That is having some nucleus. That is having some nucleus. So if the nucleus is provided in the external magnetic field, and for that situation, if we apply external radio frequency radiation, the radio frequency radiations are absorbed by the nuclei in the sample. Nuclei in the sample. So what happens when the nucleus absorbs that radio frequency radiation under this external magnetic field? What happens? Spin, nuclear spin is going to be happen. That's what the meaning. Resonance will happen. Resonance will occur. This frequency and external magnetic field will have a resonance. So when they have resonance, what happens? The nucleus may absorb that external RF radiation and spinning from low energy states to high energy states. Low energy states to high energy states. You know that the high energy states are unstable. The the atoms which are in the high energy state, they may come down. They may come down to the low energy state. So when they came to this low energy state, the atom may release photons, some photons, some radiations. That radiations we need to detect, we need to amplify it, we want to record it through some graphical analyzer, through some graphical approach. That graph will give us the molecular structures, how these molecules are structured for a particular frequency. So if you change that frequency for one of the frequencies, the molecules, the atoms may excite to higher distance. Based on the absorbance, we can have some radiation. That radiation you have to measure it. So that depends upon the. This is a way we can study the molecular structures of the, uh, uh, atoms in the cell. In the cell. So that is the basic principle of this NMR spectroscopy. Right? And then basically what happens, for a particular nucleus, carefully observe the carefully. For a particular nucleus, an NMR absorption spectrum, NMR absorption spectrum may consist of one to several groups of absorption lines, in the region of electromagnetic spectrum. So if we take complete electromagnetic spectrum, on the spectrum we can observe some group of lines under this radio frequency region. That lines refers to that chemical structure or molecular structure of this a particular nucleus. And moreover, that spectrum, that lines indicate the chemical nature. That's what I'm speaking. The chemical nature of the nucleus and the spatial positions of neighboring nuclei. So that lines on the RF region will indicate that the chemical nature of the nucleus plus the spatial positions of neighboring nuclei. Spatial position of the neighboring nuclei. Right? See, and one more, NMR spectroscopy uses RF radiation to induce to induce transitions between different nuclear different nuclear spins different nuclear spin states of sample in a magnetic field. So NMR spectroscopy uses the source is RF radiation. But remember that sample to be analyzed that should be within external magnetic field. External magnetic field. Then only in this external magnetic field and applied RF radiation, resonance takes place. The nuclei may have spin. That means that the atoms may excite from low energy states to high energy states, and they may they may come towards dawn, releasing some radiation. That rays are measured and detected, and we are plotting graph. It shows some lines that gives us that molecular structures of the ions in the sample. Okay, and I will show you the diagram, the instrumentation, NMR instrumentation, which is provided like this. Dear students, you have to recall once again that the spin, how this electron going to spin, that is quantum number, and all these basic concepts you have to study. Then you can understand this, the exact meaning of this NMR spectroscopy, right? Okay, in this NMR spectroscopy, the instrumentation presented is like this. Instrumentation. What are the instruments presented? Sample and holder, permanent magnet, magnetic coils, seed generator, radio frequency transmitter, radio frequency receiver, and readout system. Readout system. See this and analyze this diagram. So it is a radio frequency transmitter. Radio frequency transmitter. And what it is? It is a magnetic. It is a magnet, external magnet. Provided is a sample. Sample. To the this sample is within the external magnet. For the sample, we applied some radio frequency through some transmitter. Radio frequency transmitter. Fine. And this is connected to this sample. This there are two connections to the radio frequency amplifier. One is from the radiated emission, right, and to some external magnetic field. So it is radio frequency that is rejected, that is amplified, and first of all amplified and detected. After the detection, that is again amplified if required. That is given to the some recorder, some recorder. Directly can give the some oscilloscope recorder, or if you take other recorders, separate recorders are also available. So that if you take this on y-axis, y channel is output of the detector. From x-axis, you can take from series generator. From series generator, you can take x-axis. So y nothing but reject output, x nothing but through some magnetic, through some series generator. It decides some graph on the screen. That graph will give us that uh, the sample analysis. Sample analysis. Okay, you will see that and elaborately what are the instrumentation presented in this, and see sample holder is a glass tube with 8.5 centimeter long, 0.3 centimeter in diameter. It acts as a sample and holder. And permanent magnet. It provides homogeneous magnetic field at 60 to 100 megahertz. Magnetic coils. These coils induce magnetic field with when current flows through them. Right? And field generator to produce the equal amount of magnetic field passed through the sample. And one more, radio frequency transmitter. So which is the source? Radio transmitter coil that produces a sharp, powerful pulse of radio waves, right? And radio frequency. Radio frequency, a radio receiver coil that detects receiver radio frequencies emitted as nuclei relax to a lower energy level. And radar system. So it may be computer or any gap. A computer that analyzes and record the data. Okay, and this is about your NMR. That I will show you other other uh, slides which will be useful for your people.